Hello everyone. Today I'm going to present a talk on three musketeers, Sherlock Holmes, mathematics and Python. So in today's talk, I will briefly discuss about forensic investigation process, then Daubert standard and Python, then few real world problems, then finally digital forensic applications in Python. Now when we say mathematics, maths is everywhere. It's around us. You take sports, maths is there. You take music, maths is there. You take any real life scenario, maths is there. Maths is also part of nature. So similarly, we have got some applications with respect to forensics. So why math and forensics? So before discussing that, let us see the definition of forensic science. It is the use of scientific methods or expertise to investigate crimes or examine evidence that might be presented in the court of law. So basic goal of forensic science is to find out the evidence and present it in the court of law. It's a highly scientific process. So mathematics can be used to determine how crimes are committed, when they are committed, and who committed them. So basically forensic scientists, they analyze crime scene for possible clues pointing towards suspects and evidence. So few of the mathematics concepts which are widely used are mentioned here, but of course these are not the only ones. There is no limitation actually. So some of the concepts which are mentioned here are measurements, trigonometry, proportions, handling data, probability, distributions. Apart from that, you can also go for many statistical concepts, even calculus, differential equations. It depends on what kind of problem you are solving. You may also need to make use of machine learning concepts also. It depends on what kind of problem you are solving. But in this talk, we are going to address very basic problems. So some of the forensic applications which uses mathematics are like lie detection, then determine the time since death, then to determine whether it is an accident or a suicide or a murder, then calculate the percentage of concentrations in blood, then compute blood stain thickness, then perform blood spatter analysis, then ricochet analysis and aspects of ballistics and other applications. So when we say forensic investigation process, as I have said, it's a highly scientific process and as well as it's a legal process. So if we don't follow the standards, if we don't follow the procedures laid out by the regulators or the government or the law enforcement agencies, then whatever evidence we produce out of this process, it may not be acceptable in the court of law. So there are basically 6 steps in forensic investigation process. So first one is identification. So in identification, we basically visit the crime scene, or basically investigation officer visits the crime scene and try to identify the different clues. In second step, investigation officer collects the different objects. These objects may include, say, in most of the times I give examples of cyber forensics. So they need to collect the systems, pen drives, even the cables, and they also need to ensure that the system status is maintained. Say for example, if the system is on, then they should not turn it off. If the system is off, then they should not turn it on. So that is because if you turn on or turn off the system, then there's a possibility, or most of the times it happens, that the evidence may be tampered or evidence may be lost, especially the evidence which is present in the volatile memory. So whenever they are collecting a system, so they do live forensics. Say for example, they simply just pull the plug and take the laptop or computer to the lab to perform other analysis. The next is the validation of the objects collected. There are actually several forms, so they need to record what all things they have collected and when they are collected. Then fourth step is examination. So in examination, basically the analysis is performed. So here actually the various concepts are used because we have collected the evidence. So on this evidence we need to perform analysis. We need to find out the clues. We need to relate the evidences. We need to find the correlation between different pieces of evidence. Then next is the preservation. In preservation, what happens is whatever objects or whatever things you have collected, those needs to be stored in a secured place. So secured place means even the temperature of the room should not affect or should not tamper. Even some magnetic devices, if they are not stored properly, then the evidence may be tampered. Okay. So there are some bags like called as Faraday bags or electrostatic bags. So in those bags you need to prevent your physical devices, and it has to be stored in a proper room temperature inside a locker so that any unauthorized person should not be able to access it. Then final step is the presentation. So if you have followed the steps prescribed by the regulators or law enforcement agencies, then you can present it in front of the court. Now, why Python? That's because there is something called as Daubert standard. So in United States, I'm not aware of laws of United States, but it's an example which is mentioned, and many times it's taken as a standard. So the Daubert standard is a rule of evidence regarding the admissibility of expert witness testimony. So a party may raise a Daubert motion, a special motion in limine raised before the during trial to exclude the presentation of unqualified evidence to the jury. So last line is very, very important, to exclude the presentation of unqualified evidence to the jury. So if you don't follow the procedure, then it may result into that. Then court has suggested some illustrative factors. So these illustrative factors, you can call it as a scientific methodology. So what are these 5 illustrative factors are? Has the technique been tested in the actual field conditions and not just in laboratory? Then second one is, has the technique been subject to peer review and publication? Then what is known or potential rate of error? Then do standards exist for control of techniques operation? Then has the technique been generally accepted with the relevant scientific community? Now why Python is because there's one-to-one mapping between Python's features and these illustrative factors. So in 2003, Brian Carrier published a paper that examined the rules of evidence standards, including the Daubert, and compared and contrasted open source and closed source forensic tools. So on examination, he found out that using the guidelines of Daubert tests, he has shown that open source tools may more clearly and comprehensively meet the guidelines of the requirements that would closed source tools. So if we see the questions again here, so the first one says that can the programmer algorithm be explained? So this explanation should be explained in words, not only in code, because legal experts may not understand the terminology of programming basically. Then has enough information been provided such that thorough tests can be developed to test the program? Then have error rates been calculated and validated independently? Then has the program been studied and peer reviewed? Then has the program been generally accepted by the community? So if we see the Daubert standard and the Python's features here, so there is one-to-one mapping. So that's why we are going for Python. So we can also go for some other programming language which is more open source, but provided it satisfies these illustrative factors and conditions. Now let us discuss few real world problems. So first one is pressure of a shoe print on a soft ground. Then let's discuss next problem after that, suicide, murder or accident. Then okay, so the first one is pressure of a shoe print on a soft ground. So when I was in school, I was in scouts. So in scouts and guides, it's generally they are trained, right, to observe the footprints, right? So basically footprints of animals are observed. So similarly here, the measurements are taken of the length of the shoe prints, and the depth and the how far apart the prints are. So these are the parameters. Now you can draw a conclusion here. The taller the person, the longer the feet and the stride. The bigger the person, the deeper the shoe print. Then to compute the pressure in this context, you can use the formula P equal to m into g, m multiplied by g divided by a. So where g is equal to 10 ms raised to minus 2, then where m is the body mass and a is the contact area with the surface. So you need to manually measure these things with a tape or a scale and put those values into the formula in order to determine the pressure of a shoe print. So depending on the output, you can decide whether the person was taller, whether the person was a bigger person. So based on that, it can point to some suspects. Then second one is suicide, accident, or murder. So let's assume that there is a building, and from that building some dead body has fallen, and we really don't know whether it is accidental fall or whether it is murder or somebody has murdered someone and thrown the body. The criteria here, you can see here that there's a graph. So this graph is distance versus height. If it is an accidental fall, there is no initial launch angle or initial jump angle. Okay, so it will be closer to the building. But if it is a suicide, then the person will put some effort, right? So there will be more jump angle. So because of that, body will fall apart from the building. So there will be more distance between the body and the building. Then similarly murder. So somebody might have killed someone and tried to throw the body. So in that case, it will be less than 21 to 38 degrees. It may not be 0 degrees, but it will not be between 28 to 38 degrees also. So it may be close to 0 degrees. So you can consider it as 5 degrees or 10 degrees. So there is excellent book which is mentioned here as a source. So I strongly recommend that you can try to get that book. And there are lots of examples which are mentioned there. So that is Essential Mathematics and Statistics for Forensic Science. Now once you get the values, you need to put the values into this formula in order to determine y. So depending on the value of y, you can determine whether it is accidental fall or a suicide or a murder. So these are all direct equations. So you need not have to write longer programs. Just a single line statements in Python or just 2 to 3 line statements in Python will do the job. Then Pythagoras theorem. It's a very famous theorem. So you already know about Pythagoras theorem. So it states that the square of the hypotenuse is equal to the sum of the squares of the other two sides. So let's discuss the problem here. So the problem is titled as artifact smuggling. So here the authorities have a video evidence. So footage from a CCTV camera of a possible suspect in the museum break-in. So the suspect was seen carrying a briefcase, and the dimensions of the briefcase are mentioned. So it's 20-inch long and 16-inch high and 3-inch wide. And one of the artifacts stolen was 24-inch long and 2-inch wide. Now investigators now have to determine whether the artifact was possibly smuggled in out of the museum inside the suspect's briefcase. So here Pythagorean theorem can be applied on the dimensions of the briefcase. So it is 20 square plus 16 square, so we get 656. Square root of 656 is 25.6 inch approximately. Now if we consider the artifact's dimensions, so we may not be able to fit the artifact either in horizontal direction or vertical direction, but definitely we can fit it in diagonal direction. So because of that, we can conclude that artifact was smuggled. Then the next case is the resolution of human eye. Now we know that the human eye has got certain limitations. So we cannot see infinite, right? Infinite distance. everyone has got their own limitations of the eyes. So here we need to consider an example of a witness statement concerning the identification of an individual valid given that the suspect was the same distance away at the time. So here the fundamental result underlying this is that the unaided, that is he is not using any additional devices, and ideal human has an angular resolution limit of around 1 minute of arc, which is equivalent to 0.0003 radians. Now if there are some aids like specs, then again it may change depending on the situation or the capacity of the person's eye. Now such resolution limit means that any two distinct features in an object that subtend an angle greater than this will be resolvable by an eye. Otherwise features will merge and you can see that the pictures are blurred. So if a particular features are separated by the dimension d lie at a distance L from an observer, then by the definition of the radian we require the following condition to hold for the object to be resolvable. So that is d by L should be greater than 0.0003 radians. Now let us consider example. So now here a witness with perfect eyesight who viewed a suspect from distance of 200 meters in daylight claims that he was wearing a striped jumper with the stripes being around 4 centimeter wide. So now we need to determine is this statement scientifically reasonable. That means we also want to determine whether the person is telling truth or he is lying. So after calculating, so we get a value of 0.0002 radians. So it is not satisfying the previous condition. So we can conclude that the person is lying, or his evidence or his witness cannot be considered. Now this is an interesting problem, that is bank account or fund trail analysis. So in India basically most of the investigative agencies they have the requirement of this application. So they usually conduct lots of hackathons on it in order to find out the solution. So the most common and continuing offense in recent times is that the money laundering. So to make it easier for the police to trace the illegal origin of money and undo the complexities created in a series of bank transfers, so police department was looking for a solution that facilitates efficient analysis of bank accounts to identify the links among them. So basically how money laundering scenario works is it's mentioned in this diagram. So there is a sender and there is a receiver. Now the entire process is divided into three layers. First one is placement, second one is layering, and third one is integration. Now the sender gets the money and sender is going to deposit the money into multiple accounts, right? Again these multiple accounts belong to several people. Now those people in turn will again divide the amount and again deposit into multiple accounts. So it's a long chain, right? And the difficult part here is that they are not depositing the money into single organization, they are depositing the money into multiple organizations. So that's a challenge, because when police get the bank statements, they need to get the statements from the many banks. And the challenge here is that each bank produces a statement in a different format, right? The biggest challenge itself is, before analyzing, is to bring all the statements into unified format, then do the analysis, right? Then finally what happens is the amount will reach the receiver. Now you can see here that there are some red lines and there are some green lines. So when we see green lines, that's a genuine transaction, because the money is not dividing into multiples and it is not depositing into multiple accounts. Basically it's not following this three layers strategy, that is placement, layering and integration. Whereas the fraudulent transaction chain, it follows these three steps, that is placement, layering and integration. So the goal of the investigation officer is to identify this chain so that they can hold responsible all the people who have been involved in this fraudulent or money laundering transaction. Now the solution. So the solution is that each bank produces uh, gives a different statement and it will be in a different format. Now there is a formula or there is a law called as Benford's law. So this is an interesting law, not a new law, but it's a century old law. But this can be used to identify the frauds in the bank accounts. So after that, you can import the data of suspicious accounts, then convert it into unified format. You can also check it with PEP, RCA and sanctions data. Then generate a graph showing the links between accounts and the transaction. Then apply machine learning algorithms above the graph. Then predict the possible money laundering and generate the chain of accounts with the fraudulent transaction. Now the important thing here is that generating a report, right? And before generating a report, it has to record each and every step for generating the evidence. That is very, very important with respect to any forensic application. Of course, we can do the same thing with using Microsoft Excel also or spreadsheets also. We can just apply some direct formulas and we can get the analysis. But we will not be able to record the steps. So if you're a opposition lawyer, if if other lawyer asks how you arrived at the result, then you will not be in a position to defend. So that's the problem. So that's why here we need to record each and every step. Now for recording each and every step, we can use Python's logging packages. So that will help us a lot. Now what's a Benford's law? So it's called as phenomenological law, also called as first digit law. So it's going to extract the first digit of the numbers. So numbers means the amount which is deposited or basically the amount of transaction. Then it's going to extract the numbers from 1 to 9. And if we see the probability of each number of occurrence is 11.1%. But there's a probability table. So the digit 1 tends to occur with the probability of approximately 30%, which is much greater than the expected 11.1%. Now, this is a law. Basically, P of D is equal to log of 1 plus 1 by D to the base 10. So where D is the values of leading digits from 1 to 9. So what is the approximate percentage? So you can see here, number 1 is approximately 30%, 2 is 17%, 3 is 12%, right? And so on. Now, if we write a Python program, there is actually a small package called as Benford's law. So you can directly install it, and it's a small package, but you can also write a very small code and get the result very quickly, because you need not have to even draw the graph with Matplotlib. So first step is again import the Benford's law package, then use pandas, right, and read the statements. So usually banks gives you statement in the form of PDF. You need to convert that from PDF to CSV. Again, there are packages in Python which will help you to convert the PDF file to CSV. So import the content from CSV file to data frame here. Then create the objects. So pass the parameter basically here. So use Benford's law method. Then set the alpha is equal to 0.05 and method as chi square. Then you have to fit the data. So that what that will do is it will draw the distribution. So here we are drawing the distribution for first digit, second digit and the third digit. So now you can see the graph here now, right? So if you have seen the similar graph in the first slide of Benford's law here. So it resembles almost same, but the problem is that the probability here it is 35.1%. So that is more, and for second case it was less than 17%. So that means what is that there is anomaly and it is detected. So similarly, you can go ahead and do the experiment with respect to second digit test. So here also you can see that there is lot of variation here. So similarly with respect to third digit, so Benford's law was a very simple method to identify the suspicious transactions in a bank statement. Now next is hash functions. So we know that hash functions are related to again cryptography, right? So basically whenever we collect the evidence, we actually take the snapshot of the entire system. When I say snapshot of the entire system, it consists of all the configuration files, the content stored in the RAM, everything, right? Not only the data stored on the hard disk. Now when we perform analysis, we are not going to perform analysis on the original data. That's because there is a possibility that that data may get tampered, right? So what we do is we take the snapshot of the system, make a copy of it, then perform the analysis on the copy of the data. Now before performing the analysis, we compute the hash of the original image and the copy of the image. So both should match. If it doesn't match after analysis, then that means that there is some interference which is happening through the program. So your program must ensure that whenever it is performing the analysis, it is not interfering with the evidence. Okay. So basically hash functions ensure that integrity of the evidence is maintained. So it's a very small code here. So we are using hashlib library and SHA-256 method, and using a simple string to compute the message digest using SHA-256 algorithm. Even if there is a small change, right, the hash code will change. So small change in the input will change the hash code. So that means that integrity is compromised. The next is forensic indexing and searching. Now this is also very, very important. What happens is whenever we take the snapshot or whenever we take control of the hard disk of the criminal, there is actually huge data. So there is actually a data in terms of gigabytes or even in terms of terabytes. So here you really don't know what to search there, right? It becomes very difficult. So in that case, you can use simple file search and index functions in Python and try to find out the clues. Now there is a library called as whoosh. So it's basically used for forensic indexing and searching. It's basically a library which helps you to build your own custom search engine. Okay, so you can decide which data to index, and you can parse it and you can query the same data, right? So this is how it works. So first import the data, then define the schema. So in schema we are defining the what is the path, what is the context, and what's the title. Then add to the index, then use query parser package and search for the clues. So next is forensic evidence extraction from the screenshot. So I don't have much time. So basically Pi screenshot takes the snapshot of the hard disk, not the hard disk, the screen. So you can take full screenshot or partial screenshot. So in forensics, performance does not really matter. So let me go to the last slide. So forensic investigation is a highly scientific process. So since Python is a scientific computing language and conforms to Daubert standard, it is one of the most suitable languages for developing forensic tools. In forensics, accuracy of the clues and evidence matters rather than the performance of the application. Thank you everyone for patient listening. So if you have got any questions, I can take up.
If there is no question, we thank you so much, Gajendra. And we have the speaker here. We can speak directly.
Hello, hello.
Thank you
Yes,
so
I do
much.
have a question. Is it on this one? Can I use that one?
Do you have any question? I do. Oh, okay, perfect.
Hello. Yes, I just have a quick question. I might be the only person here who is not a programmer by trade. I'm actually an attorney. I work for the government as an attorney, and I am also on the prosecutorial side of being an attorney for the government, being trained in digital evidence as well. So really what I want to ask you, and all of this was brilliant. I want to follow up with you more. I would love to continue to have a dialogue with you about this and using this moving forward. But I want to know from you, how are we going to be able to translate this to a jury? Because I'll be honest with you, this is all brilliant. And as a attorney first turned programmer, I understand what you're doing, but how is John Smith, Jane Q. Public, etc., that we're selecting off of a jury, how are these people going to be able to understand what you're saying and then tie that to, say, for instance, a financial fraud case or a larger scale case of that nature? Because, everything that you said, placement, layering, integration, that is actually what we, on the other side of this, use in our elements of trying to prosecute financial crimes. So this is all actually very cogent. But what I really want to try and understand is, if I were to call you as an expert witness, how are we going to be able to take this and then make it more digestible for the non-programmatic community?
Yeah, actually, that's a challenge and a very good question. So we really need to have people who understand technology and the law. So only then a single person who understands both the sides can actually convince common people as well as the judge or magistrate.
And then I suppose, just another follow-up, obviously, because I'm extremely interested in this. So obviously we're going to use logs to sort of show our steps, how we did this, what we used, how we got this result. However, how are we going to be able to take the explanation of that, but then are we going to have to explain how logging works as well before we explain what the logs explained?
Yeah, so the second part, we again, as I have said, we need a techno-legal expert who can actually explain the process. And as you know, logs are not in, many times, they are not in human readable form, right? So whenever we are building custom applications like this, we have to make sure that logs are in human readable form. So whenever something is recording, we need to add appropriate comments automatically so that it becomes readable and it becomes understandable by the non-technical guys. Yeah.
Thank you. I appreciate it.
Thank you.
As a non-attorney, isn't the harder challenge getting it past a judge?
So that's also a great question. And what essentially occurs before the trial will happen is that we can do what's called maybe an in-camera review, or we will have some type of evidentiary hearing that will just be the attorneys and the judge, and then that is the process in which we would explain this to the judge, or we could do what's called motion practice, and then I would draft a legal document in which I would explain this entire process, how it works in the written form, and then I would submit that, and then the judge would review that, and then the judge would then decide, I'm going to allow this evidence into the record, and then it would be up to us, once it has been accepted via that in-camera review or through motion practice, to then explain it to the jury, and then the jury would have that evidence, and then they would be able to decide then how they would apply it to the legal burden that they would have as the jury. So